I'm going to walk you through the power rule. The power rule is going to govern polynomials, square roots, cube roots, all sorts of things, rational expressions, and then we even have something that looks like a combination of all those things. The power rule is a rule that kind of governs those. So the power rule says bring down the power, decrease the power by 1. And this is kind of in the abstract what we would do here. So if we had some function y equals a times x to the n, the derivative, right, y prime or dy dx, is going to be a n x to the n minus 1. N minus 1 is decreasing the power by 1. And then when I say bring down the power, I mean multiply the lead coefficient times that previous power. Okay, so let's just kind of go through the examples and hopefully you can kind of catch on. So this is some linear function. Now, what do we know the slope of this already is? Right? What's the derivative of 4x plus 5? What's the slope of 4x plus 5? Well, we know the derivative better before. So if the power rule doesn't give us 4, then something has to be wrong. So dy dx says bring the power down. Remember, 4x is x to the negative x to the first. So bring the power down. 4 times 1 is still 4. Decrease the power by 1. Well, if I decrease the power by 1, it'll become x to the 0. But x to the 0 is just 1, and I get 4. Well, what happens to this guy? Well, we know that the derivative of a constant is 0. But the power rule confirms that. That's really 5 times x to the 0. If you brought the power down, 5 times 0 is 0. 0 times any finite number is 0, and then the power rule works. And it gives us that the derivative of this line is 4. And we already knew that. Right? The slope is 4. Okay, let's look at this quadratic. Now where the slope will actually be some function. So dy dx equals, bring the power down, 3 times 2 is 6. Decrease the power by 1, makes it x. And here we're taking the derivative of 5x, and we just get 5. The derivative of 1 is 0. So then the derivative of this quadratic is this. Again, let's throw another one in there. What if we just had something like y equals 5x to the 4th? What would be the derivative? Again, the derivative is bring the power down, meaning multiply that by 4 and get 20, and then decrease the power by 1 and make it a cubed. Okay, let's go over here to then some of the harder applications of the power rule, because so far what we've said is that polynomials is pretty easy. We just multiply and then decrease the power by 1. Same thing here. You might want to think of this as 4 times x to the half, because then the rule might be a little easier to apply. Dy dx is equal to bring the power down. 4 times a half is just 2, and then decrease the power by 1, right? Decreasing the power by 1, a half minus 1 is negative a half. Negative a half really is just the square root in the denominator. Okay, and we'll look back on why that actually makes sense here. Okay, same thing here. Bring the power down, which is going to be 1/3. Decrease the power by 1. Subtracting 1 from 1/3 is that, which again in this case is going to be 1/3 all over x to the 2/3 in the denominator. Here, same thing. Dy dx is going to equal 2/3 x to the negative 1/3, which is the same thing as 2 over 3 times x to the positive 1/3. If we look at here, this is the same thing as x to the negative first. If we take the derivative, following the power rule, bring down the power, decrease the power by 1, and then we'll rewrite that as negative 1 over x squared. We can have any sort of big polynomial, or even, again, this isn't a polynomial, this is a combination of polynomial stuff, square roots, and rational expressions. And the power rule governs all of those things. So dy dx is equal to 6x squared, bring the power down, decrease the power by 1, plus 4. This is really just x to the half. Bring the power down, negative 1/2, decrease the power by 1. This is really x to the negative first. Bring the power down, decrease the power by 1, and then we could rewrite that as 6x squared plus 4 minus 1 over 2 square root of x minus 1 over x squared. Again, we can do power rule to govern whether the powers are fractions, whether the powers are negatives, whether the powers are cubes or ones or squares, it doesn't really matter. The power rule is a pretty easy rule to apply to all of these functions, and it gives us equations for the derivative. Remember, this is the power rule to take the derivative of things. And just let's look at how this might even make sense. If you look at this graph should look something like this. And you see how the slope of this thing is always positive? Look at the derivative. All right, that will always be positive. X can't be negative, and 2 over the square root of a positive number is always positive, and look at the slope here. Always positive. Again, the cube root graph, look what that looks like. The cube root graph looks like this. Look at the slope, always positive, except the slope doesn't exist at 0, which we would get in a future lesson, but you can't let x be 0 and be in the denominator here, but it's always a positive slope. Okay? So there are a variety of things you can look at. What about this? Look at the slope here. The derivative looks like it's always negative, but look at the graph. Look at the graph of this guy. See how the graph is always decreasing, going down, going down. Look at the derivative. Negative 1 over x squared is always positive. 1 over positive is positive, and then you apply a negative sign. The graph always has a negative slope, and the derivative tells us that exact same thing. Okay, so this is some general things. I'm going to add one more on the end, just to remind you that when you see later on, you're going to learn this thing called the quotient rule. I'm just going to remind you that if you have something like this, and you try to take the derivative of it, you don't have to do quotient rule. Quotient rule, you will learn eventually, is a function over a function. But I'm going to remind you that you can rewrite this as that. That 4 is not really a function in this case. Now it's just a coefficient. And we can do the power rule here. The power rule says bring down the power to make it negative 4, and then decrease the power by 1. And then, of course, we can rewrite that as negative 4 over x plus 3 squared. And again, when I look at this, I'm not going to think quotient rule eventually. I'm going to think this, and I'm just going to use nice, easy power rule. Okay, so let's take a look at all of those examples. The basics are right here. Eventually, you're going to learn the chain rule, and then you're going to have to multiply by u prime. But for right now, when you're just learning the power rule is a really convenient way to take the derivatives of polynomials, square roots, cube roots, 2/3 power, as well as rational expressions like 1 over x, or 1 over x plus 2, or 1 over x squared, 1 over x cubed. I guess maybe at the end, what if we just did 3 over x to the 4th? What would that be? Well, think of it as 3x to the negative 4th first, right? And rewrite it algebraically. Now take the derivative, right? Now y prime, bring the power down and make it negative 12, decrease it to negative 5, and then you can rewrite it as negative 12 over x to the 5th. Okay, so that really should be enough examples to kind of get you started on the power rule.